Welcome to the seventh part of Pharmaceutical Calculations. In this short lecture, I will be talking on sodium chloride equivalent method for isotonicity calculations. Sodium chloride equivalent method uses the comparisons of freezing point depression value of 1% of substances and 1% of sodium chloride. So basically, the E 1% here refers to the ratio of the freezing point depressed by 1% of the drug S or substance S as compared with 1% of sodium chloride. So in simple words, it means that how much it can depress the temperature of the freezing point as compared to sodium chloride. So how do we calculate E 1% of a substance? So given here, phenolbarbiturate, sodium. So we just substitute the value of freezing point depressions for these two items and you get a value of 0.23. And this value has no unit because it is a ratio. So what does it mean by this number of 0.23? So it means that 1% of phenolbarbiturate sodium produces same osmotic pressure as 0.23% of sodium chloride. So how this sodium chloride equivalence can be used? So let me give you an analogy. Let's say you are going to buy a fruit basket in London and each of the oranges costs you £1 and the kiwi £2 and an apple for £2 as well. If a fruit basket consists of 2 oranges, 2 kiwis and 6 apples, how much would you need to pay? And you end up that you only have ringgits in your pocket, so that would not be possible. So you need to change your money to pounds. So in this case, you can imagine that the sodium chloride equivalent values, the E 1% is actually reflects your currency exchange, and you're turning your ringgit to a standard, which is the sodium chloride, and here is represented by the pounds, so that you can get to compare with others. So if you're able to change something to a standard, then you can use that to compare with other ingredients. Let's look at this example. You have sodium chloride available in the system and you need to use potassium chloride to adjust the systems. First, we need to find out the E 1% for each of the ingredients. And for sodium chloride, of course, it will be 1 because it's comparing to itself. So we will not calculate for that. However, for E 1% of potassium chloride, you just take the ratio of freezing point depression value of potassium chloride with sodium chloride, and you end up getting 0.76, and this 0.76 means 1% of potassium chloride will produce the same osmotic pressure as 0.76% of sodium chloride. Then we have to find out the equivalent of sodium chloride amount in terms of concentrations present in the systems. And it's so coincident that you are given a sodium chloride. If it's not given a sodium chloride, you have to convert it to the equivalence in terms of sodium chloride equivalence. And you find out that the concentration is 0.25%. So as we know that to have sodium chloride to be isotonic, the concentration is 0.9%. So we have to minus whatever available with 0.9. So the rest of the concentrations of sodium chloride would be adjusted by the rest of the ingredients. And here it refers to the potassium chloride. So from the E 1% we have calculated, it means that 1% of potassium chloride is isotonic to 0.76% of sodium chloride. So in this case, if we have 0.65% of sodium chloride, that is equivalent to potassium chloride. So how much is it? So we just take the ratio and you're able to find the value is 0.86%. So for 200 ml, the amount of potassium chloride need is 1.71 grams. So in total up, you need 500 mg of sodium chloride and 1.71 gram of potassium chloride to make 200 ml solutions isotonic. In this example, we couldn't find any sodium chloride, so what we have to do now is convert each of the ingredients here to its equivalent in sodium chloride. So with that, you need the value of E1%. In case E1% is not given, you are still able to calculate from the freezing point depressions value for each of the ingredients and sodium chloride. So first, we convert those ingredients that is present with the known amount to its equivalent in sodium chloride. So let's take chlorbutyl as example. E1% of chlorbutyl is equal to 0.24. So it means that 1% of chlorbutyl is isotonic or produce same osmotic pressure as 0.24% of sodium chloride. So in this system, we have 2 grams of chlorbutyl in 150 ml. So it means that in 100 ml, it has 1.23 grams or 1.23% of chlorbutyl. And how much of this 1.33% of chlorbutyl is equivalent in terms of sodium chloride? So we just multiply and we find out that this amount of chlorbutyl is equivalent to 0.32% of sodium chloride. So the same happens for phenylbarbitone sodiums. And in this system, we have 0.33% of phenylbarbitone, which is equivalent to 0.076% of sodium chloride. Since we know that 0.9% of sodium chloride is isotonic, so we just minus whatever sodium chloride equivalents available in the system, and the rest should be adjusted by the adjusting agent, and in this case it is potassium chloride. So it was found that 0.5% of sodium chloride is needed, but we need to convert it into its equivalent in potassium chloride. So again, from E1%, we know 1% of potassium chloride is equivalent to 0.76% of sodium chloride. So for 0.5% of sodium chloride, its equivalent in potassium chloride is 0.66%. So for 150 ml, the amount of potassium chloride needed is 0.99 gram or roughly about 1 gram. Thanks again for your attention, and I hope that you get some clear idea about sodium chloride equivalent method and how and why we need to convert it into sodium chloride, which we know that it is a standard that is being accepted worldwide, that 0.9% of sodium chloride is isotonic, and it can be used as a standard for us to refer for the rest of the ingredients.